All right, hello everyone and welcome back. In this video, we are going to look at another example of a free response problem from the AP Physics exam. This example is going to have a paragraph length response question in it, so you can see how that might be embedded in a physics type question. This is from the 2015 exam and it is question number 4. All right, so it says two identical spheres are released from a device at time t equals 0 from the same height as shown above. Sphere A has no initial velocity and falls straight down. Sphere B is given an initial horizontal velocity of magnitude v0 and travels a horizontal distance d before it reaches the ground. The spheres reach the ground at the same time, called TF, even though sphere B has more distance to cover before landing. Air resistance is negligible. On the dots below represent A and B. Draw a free body diagram showing and labeling the forces exerted on each sphere at TF divided by 2. So what that means is that we are taking two objects. One of them we are letting fall straight down. The other we are projecting horizontally, and it's going to parabola down like projectile motion. And they both take the same time to fall. This one, because it's being fired, travels over a certain distance. So t over 2 means like when it's halfway down. So when this one's halfway down and when this one's halfway down, they would be at the same height, and that's the two spheres shown right here. So it says draw a free body diagram. A free body diagram means a picture that has all of the forces acting on the object and labeling the forces. So let's talk about the one that is dropped down. The only force acting on that is gravity. So I'm going to draw an arrow, and I'm going to call that FW. Some people like to call it FG, like gravitational force, and it would be equal to mg. And since this is sphere A, that could be like MA. Because MA is different than MB, sphere V, I think this would be like the best way to label this free body diagram. All right, sphere B, when it's halfway down, it doesn't really matter like how something is flying in the air. If something is flying in the air and it does not have string attached to it, and it does not have an engine or a brake attached to it, the only force acting on it is gravity. So even though this one's being fired horizontally, it also has, the only force acting on it would be sphere B and times G. I'm trying to see if these two spheres have the same, yes, two identical spheres. So they have the same mass. So I don't have to label them. So I could just call this mg, and I could just call this one mg. And since they're identical, these arrows should be the same length. So I should have cleaned that up a little bit. Those arrows should have the same length. All right, next question. On the axes below, sketch and label a graph of the horizontal component of the velocity of sphere A and of sphere B. Well, sphere A is being dropped straight down, so it doesn't have a horizontal velocity. So there is no horizontal velocity. So that would be like horizontal velocity would be 0. So I'm going to go like this, and the horizontal velocity would remain being 0 the whole time. And this is going to be MA, sphere A. The horizontal component of the velocity of sphere B, it's being fired with a velocity V0 or V0, however you want to say it. And the horizontal velocity does not change. does not change. So I can kind of really pick any line. I'm just going to pick any line. And I'm going to label this line V0. And then that's the sphere B. So again, it didn't matter what I picked, but for the person who's correcting your exam, they can see that you can see that this one is not the same as this one and that it remains constant. But when it said label, that's why it was really important that I labeled this y value as V0 given in the problem. All right, this is supposed to be an example of a paragraph length response question. And here it is, and here goes. In a clear, coherent paragraph length response, explain why the spheres reach the ground at the same time, even though they travel different distances. Include references to your answers to parts A and B. So again, I'm not going to write this down. I'm just going to kind of talk it out, but you can see the amount of paper they gave us to write this paragraph length response. All right, so let me say it again. Why do they reach the ground at the same time, even though they travel different distances? So when you take two spheres and you drop one and you fire the other one horizontally, since they are dropped from the same height, it's going to take the same amount of time to reach the ground. And if I was actually going to calculate it, it would be d equals 1/2 at squared. They have the same distance. They have the same g, 9.8, so the time would be the same. So as this sphere is falling straight down, the only force acting on it is gravity. This sphere is being fired, but as it travels to the ground, the only force acting on it is gravity. How do I know that? Because I can look at my free body diagram that I drew. The only force acting on each of them is gravity, and the force is identical, and that's the only force that causes them to reach the ground, and so therefore they hit the ground at the same time. This one is fired with a horizontal velocity. A horizontal velocity, I'm going to write the equation, velocity is distance over time. I'm going to put velocity in the x direction, causes the object to travel over in the x direction, so it travels over in this dx. But the horizontal velocity remains the same and causes it to land farther from the base of the table, but that doesn't affect the amount of time it takes to hit the ground. So somehow I have to put all that in words and write a coherent paragraph length response. So writing the response means you have to understand it, but can you write it in such a way that you could explain to somebody who wasn't in physics or who didn't know these laws why the time would be the same. So that's my example of a paragraph length response, and I hope that helps you see the types of questions that you are going to see on the AP Physics exam.